Tech Nuggets, Network Monitoring with SNMP. SNMP stands for Simple Network Monitoring Protocol. And the basic gist is getting information from network-attached devices. It can do a couple other things, but that's typically what it's used for. It was created as an IETF standard in 1988. It's gone through a couple of different versions that have added different things, but in essentials, it's done a great job at doing what we needed to do, which is to get information from devices. Now, the system that was created is an extensible system, and it's important to remember because it means we can expand the questions and types of answers that we get from the gear to cover new gear. It's so extensible that we can assign portions of this off to manufacturers, and they can define it. And that way, if I own a Cisco switch, I can go off to Cisco and download the library and understand that these pieces of SNMP, I'm going to ask these questions, I'm going to get these kind of answers, and it helps me understand what's going on, and it doesn't require it going through the standards body to do that. We can do that, from a manufacturer point of view. There are a bunch of standard questions, and we'll see a bunch of those in the demo, standard questions that exist in nearly every piece of network attached gear. You can ask standard questions like, what's your uptime, and what's your network interface, and stuff like that. And we'll do some of that in the demo as we go along. So the normal use of SNMP is to poll a device and receive information. We can also do traps, which are a little more complex, but it's basically the device reaching out to the monitoring software and saying, hey, I have a problem. So you can pull and push in this environment as well to get management information. And that's a fancy term for saying, I ask a question, I get a response. I want some piece of information about it. Again, pages printed over the lifetime of the printer. For a switch, that might be, bandwidth going through a port or something like that. Errors seen on a port, dropped packets, something like that. You can also use SNMP to configure a remote device. The security implications of this should be relatively obvious, and different versions of SNMP have gone after that. No person I know has ever used SNMP to configure it, but it is part of the manual. The manual is quite lengthy and does all sorts of interesting things. Mostly we just use it to get info from our gear so that we can use it to monitor what's going on our network. There's a couple of terms to talk about. There's an SNMP manager, which is the thing issuing the requests, and there's an agent that responds. The agent can also be configured to send traps to the manager, so that kind of goes back and forth. For the most part, SNMP is used for asking questions and getting answers. And earlier I talked a little about security. Here I've got version 1, version 2, version 2C, and version 3. And version 1 had very little security. Version 2 came along in the early 90s. Version 1 was made in about the mid-early 80s. Version 2 came along in the 90s and added a layer of security, but it was difficult to implement. 2C, the C stands for community. There's a community version that tried to make it a little easier. 2C's been around for quite a while, and most devices that are network aware and have any kind of level of management, we would use 2C. That's pretty normal. There is security you can put on it. More importantly, it separates the read from the write, which would be the configure portion of it, and that's where most people want it. They just turn off the configure portion and use the read portion to get information. Version 3 offers a lot of interesting encryption options for pulling data and pushing configurations. Again, can be used, don't know a lot about it, don't use it much. Most people are using it to pull information from their gear. Traps. Traps are just, they're a pain to set up. Some pieces of equipment just require traps. They're that sensitive, and you really want to know right now. Polling has the downside of I have to wait to get around to it, and I'll poll every 60 seconds. But traps mean they can come in off cycle. So if my manager is sitting there polling that device for a piece of information every 5 minutes, because we don't want to fill up the network with stuff, if something really important happens, I can set up traps to be sent to the manager immediately. And that way I'll know right now when there's a problem. So it sounds really good, can be a little tricky to get set up. Again, haven't done a lot of it, because I've never had a burning need, but it is possible, and it is fairly useful. All right. SNMP has kind of a stigma that goes with it for using it. It gets a little murky, And we're going to talk a little about the part that gets excitable. I talked earlier about this extensible system, and that's kind of what we're talking about here with OIDs, object identifiers, and MIBs, management information bases. And the best analogy I can come up with for an IT person is that an OID is like an IP address, right? It's numbers, it's fairly unintelligible. You're probably not going to remember them. The MIB offers two things that are very important. The MIB offers a very much DNS-like kind of front end, right? We can see here that for the MIB, the OID is and the MIB discussion here are the same thing. So system.sysuptime.0, the OID for that is that big long string of numbers. So in DNS, we would use, host names to replace an IP address. And the MIB allows us to do that. But the MIB also gives some more background information for what kind of data should I get back? Should it be an integer, a float? What kind of data am I going to get? What kind of questions should I ask? And many manufacturers use that to set up the hierarchy for their gear. They're going to use this part of the MIB. They may have a 500 meg MIB for a little teeny switch, but you're only going to use a little piece of it. But you load the whole MIB and the gear will know, when you ask it the right questions, it will know this piece of gear uses this piece of the MIB file, and you can start asking the right kinds of questions. Now, the verbal discussion of that seems pretty easy, but getting this relationship set up and am I getting the data I want is really hard. And it's one of the reasons monitoring has this stigma of being an art, because getting what you think you're getting and what you want can be difficult and challenging. All right, so we're going to go over some of the command line for SNMP, and when I do the demo, we'll do some demo with command line. I've got a couple of GUI tools in Windows that I use. I'll show it a little in Wireshark so we can see what's going past. You can collect a lot of data fast. So we're going to start with just asking for like one piece of information, and then we'll go on and we'll be able to ask for like whole rafts of information. There'll be just tons of it. Sorting through it can be quite challenging. All right, so in SNMP get here, the -C is asking a community option. So in version 2, which is what the -V on the line there means, 2C, is asking for a version. And in version 2, we have this sense of community string. It's basically what's the read password, for lack of a better word. The standard answer is public. So if you just turn on SNMP on a device and set it for 2C, you probably have a public community already set and no community for reading, or for writing, excuse me. The -M is asking me to import all the MIBs. So that's saying bring them all in. I could specify if I just wanted a few. I can put them in a directory and specify the directory. But in this case, I just say load them all. The IP address of the device I want to go look at, I'm going to go ask it questions. And in this case, since I loaded MIBs, I can use, the language for it, system uptime. In the second one, you can see I've done a get. I've actually added the -M, but I don't need it because I asked for it by OID. It's the same request. If you sniffed it, you'd see the same thing. But in one case, I used the number. In the other case, I used the information from the MIB. There are standard MIBs that you'll get that are for asking standard questions. It's sort of like being asked, what's your zip code? Everybody's got one. We just ask that standard question. System uptime is kind of one of the standard questions. A lot of SNMP history comes from network devices like switches. And so a lot of the standard questions that you can ask have to do with network interfaces. Since it has to be a network attached device, makes sense that you're going to want to ask it network kind of questions. So you can ask a whole host of kind of standard questions, and I'll show a little of those in the demo. Down here at the bottom, it gets a little exciting. Once we start getting into this, you can get a lot of information fast. And with an SNMP get, you're basically doing a question and an answer and a question and an answer and a question and an answer. And in older networks, when we were really limited, that could take up a lot of bandwidth. So they developed this concept of SNMP bulk get, which basically goes to a piece of the hierarchy. And you can see in the two commands, I've actually shortened it by 2 numbers. I chopped off the 3 and the 0. And so that part of the tree is now open. And if you were to run that command, you'd get, well, depending on the device, when I ran it, I got about 150 lines of stuff because it just keeps going down the tree and iterating through the tree. So it'll do .1 and it'll just keep going until it runs out of information. And the way it iterates through that, it can find all the different ends of all the different parts and give you all the information. But it'll do it in such a way that it'll go ask, get all the answers and bring it back to you in, less packets. So it's less data on the network. One of the best tools I found while I was doing research for this is this SNMP translate. And this will translate from the MIB language into a straight OID. A lot of times it's nice to know that you're poking a specific ID. This is true when, and I don't have to load MIBs to do it. So if I'm trying to be efficient on maybe a piece of IoT equipment, don't want to load all the MIBs and have it run all the CPU cycles to dig through the MIBs, and I just want the OID, I can run this. It'll spit out the MIB, or it'll spit out the OID, excuse me, on one system, and then I can pull it over and use it somewhere else, and I know what I'm getting because I'm using the OID for it. So oftentimes that's not uncommon. All right, so there's a bulk get as well, and in this case you can see I've set it up to just ask for interfaces. So this will be all network interfaces. It'll just ask for it all. Now walk gets really exciting because you can back walk up to a point where it will ask at a high level in the OID tree, and will walk its way through the entire tree, sucking out information. And you'll notice there's also a bulk walk there, which will try to bundle it up into bigger packets, bigger frames of data, so we're not hammering the network so hard. All right, let's go on to the practical demonstration. I'll show it, at the command line. I've got, like I said, a couple of GUI apps that we'll show, and we'll have a little demo. All right, so I've got my bash window open here. I've installed SNMP get command. It's not a stock command, so you have to install it. And I've got the most basic query, right? We're going to do a version 2C query to the community public to that IP address at that OID. And so it's asking a very specific question of one OID, right? We're doing an SNMP get. This OID is used for uptime. So how many seconds since you've woken up? Most network devices will track uptime. It's pretty standard stuff. You can see there, it's going to return this number right here. This is called time ticks. It's the number of seconds. And the SNMP program, SNMP GAT, will do a little math for you and tell you what the day and time is. We're going to show the same command, and I've got my commands staged off camera here, so I can just sort of paste them in. But we're going to do the same command, but this time we're going to use the MIB to ask the same question. So system.sysuptime.0, so the first counter, and you can see I've got the -M option to say load all the MIBs. And what we're getting back is a little more information. To be fair, I'm not sure what the bad operator error message means, but we are getting the correct answer. But instead of an OID like we got with SNMP get, the original SNMP get, we get the system uptime instance. It's giving us the ticks. They've changed a little bit because there's been several seconds since we ran it, but it's telling us where it's pulling its SNMP data from, its MIB data from, that kind of thing. All right, so we'll also be able to do a bulk get. And this is the one where I shortened the OID a little bit on the end. And in fact, I don't need this -M, so we'll take it out. And it should return a bunch of information as it works its way down the tree, but it'll grab it all in one go instead of asking individual questions. When we did our gets, that's one question, one answer. And a bulk get, as it works its way through the tree, we'll get all of it at once. Instead of doing multiple gets, it'll do one big get and bring it all back, so less network traffic. And therefore, we can see here, I've got all sorts of information, right? Uptime is in here, right? .3.0. Since I started at 1, you can see the number from here back is going to be all the same. But we went through and iterated all through it, 1, 2, 3, 4, and we can go down and find different things. And if I keep backing up, we'll keep getting more and more and more information as we go. If I wind up doing this kind of stuff, we should get, we may get more information. It just depends on what else is in that OID hierarchy as we go. So let's try a couple other things that I know are going to spit out a ton more data. Let's clear our screen here. And this is an SNMP walk command. So we're going to use the MIBs, and interfaces is a standard thing to ask for. I want to know interface information. Like I said, the history of this command was heavily used for switches. So asking about switch interfaces is a very standard thing to want to do. Of course, if you're a network attached device, you're going to have network interfaces. You have to return the data. So asking about the interfaces on a device is a very standard question. And with a walk, we're going to get a lot of information. This is a ton of information about different interfaces, IP addresses, the counters, our number of packets. We need to go through the MIB to figure out, what does all this mean? Lots of network monitoring software, Cacti, Nagios, MRTG, PRTG will understand this by default and be able to process through it and be able to sort it in such a way that you'll know what it is and it'll be useful to you at that point. We're going to scroll up here to the top. You can see I've got some Ethernet cards and lag interfaces, and this is telling me about all the different Ethernet cards that it knows of in the box. And it's not all the information, but it's a good bit, you know, MAC addresses and all that kind of good stuff. Yeah, it's pretty useful kind of stuff. So we're also going to do this here with a bulk walk, which should return the exact same information. But again, instead of doing multiple gets, it's going to do one great big get and bring it all back. And there you go. That's kind of the same thing. So next I'm going to show up a Windows application that's going to do something very similar. And then we'll do a little sniffing, and I'll dig through the sniffs so we can see exactly where that information is. So between the last snippet of video and this snippet of video, I had a little discussion with one of my colleagues, Professor Saunders, and he introduced me to this very cool utility called SNMP table. It's going to take the bulk walk data that we saw that was just streaming all over the place and stuff it into a table, which is very cool. So I've added a couple of options here. I'm using the command SNMP table, and this CW says be 90 characters wide. So that way it'll fit. Now I'll take it off and you'll see what happens. It gets really, really wide. You have to zoom way out to see everything. But we hit enter and it's going to barf out all sorts of data. But now it's going to put the data in some table formats. So we see what the hell's going on. And we can see errors in and errors out. This begins to be very useful information from the standpoint of what am I looking at? What's it doing? Why do I have this? What does the data actually mean? Physical addresses and things like that. Becomes very, very interesting at this point. And here's the version of it without the CW90, and you'll see it puts it way in this crazy format. If I zoom way out, I begin to get a table again where every single column is represented, but it's really, 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 really small. So the C90 does a nice job with that. There's one other command I kind of wanted to show. I talked about it in the slides a little, and I'm going to throw it in here, and it's the SNMP translate, which can translate from a MIB to an OID, or from an OID to a MIB. And you can see here I popped in the SNMP translate from my copy paste here, and it turned around and checked for uptime and it just gave me the OID. And we'll do the same thing in the other direction. Now you have to have the MIBs loaded every time for this, because that's the point, right? It's going to translate back and forth between OIDs and MIBs, so you're going to have to load the MIBs every time. And there you go. So it's translating back and forth. I did do a little digging. Apparently there's some sort of error in that file that does SNMP v2 for PDUs. We looked at it a little. I couldn't quite figure it out. But it doesn't hurt for what we're doing because we're not really using that MIB file. So it shouldn't matter. But you can see here SNMP translates going back and forth between an OID to a MIB and a MIB to an OID. Very useful stuff. All right, we'll go back on to the GUI stuff, but I thought this was kind of cool, so I threw it in. All right, so this is a piece of software made by Passler. They're the same folks that make PRTG, which is a network monitoring software. It's a freebie. Download it from their website. Doesn't cost anything. Runs in Windows. Does a really nice job at kind of bundling together SNMP get, SNMP bulk walk, that kind of stuff, and just outputs it in a text file, which is the big white thing over here. You could set up tests to run every so many seconds. Down the side here, you can see it's got a variety of standard tests. Device uptime is a very standard test. We can ask it to scan the interfaces, which is also a very standard test. But we can also go in here and begin to ask for custom OIDs, either MIBs or not. It'll walk. We can load MIBs into it to force it to do things. At the top here, as we talked a little about earlier, it can be very important at what the source of your questions for SNMP are, because if you're on the wrong network, it might get blocked by a firewall or something like that. So you can pull down here and pick whatever address source you want your SNMP queries to come from. In this case, we're poking the same thing we were. We're telling it what protocol we want to use. We're going to use v4, what version, and community strings. You can see there's other stuff that's grayed out based on which ones I would use or pick, and some timeout information. So we're going to do a basic device uptime check, and it's going to be pretty basic. It's going to do basically an SNMP get. It's going to run. It's going to give me the basic data. It's kind of what we're looking at here. It's not that exciting. It's not that different. It's just a little easier to work with. Can be kind of nice to put it on repeat where you can get it to do it, and that way you can play with the other end and make sure you've got your SNMP agent settings right, or maybe there's a firewall in the way. You can have it sit and run the same test again and again. Can Wireshark it this way, and you know what you should be seeing, that kind of stuff. So let's go down here and do a scan interfaces. Again, we've done this kind of stuff when we're with command line, so the information should look very familiar. And it's going to take quite a while to go through and dig through all the interfaces. Again, we saw this kind of while it was doing that in the command line. This will give us a textual GUI output. GUI quotes around that for GUI because it's not really very GUI. We'll wait until it gets done here. I might do a little time compression. All right, so there we go. And again, it's not like it's the SNMP table where we were getting lots of useful information in a table. It's the same information, but, you know, we're seeing IP addresses and hosts and all sorts of great data is in here. Again, this is sort of what our network monitoring software would do, would be to take this data and make big sensors out of it, poke it on a regular basis, make sure it's up and working, that kind of thing. Let's go back and do we're going to clear the log here. We're going to do a device read uptime. There we go. Now I'm going to show some data that I collected that is this query, and then we'll tear apart the Wireshark for it and have a little look at what's involved in that. This is some data that I captured while doing SNMP GET requests for uptime. So up here at the top, we can see in the, in the different lines here for summary, we can see I've done a bunch of GET requests and then we get responses back. And a lot of that info is right there in the info column of the summary line. We can see that it came from my machine, going to this machine, and I put a filter in for SNMP. That's what the green line at the top is, so that I can just see SNMP queries and responses. And so it'll show me all that kind of stuff. Down here in the middle frame, we can see that I've opened it up, right? It's a UDP packet. And I've opened it up and it gives me the version number, version 2C, the community. So this is from our request, all the information that went out for our request. It's got a request ID, but as we start to open up different parts, we can see down here at the bottom, we've got an OID, and that's what it's asking for. And as we see, I'm going to go up and click on the response, we'll see a lot of the same things, right? UDP will come back, it'll give us some of the same thing, but this piece of data will show up, which is value and time ticks, which is what we saw. The utility itself will translate that in and do the math for how many days, weeks, months, years, whatever it is, and we'll translate that out. But all the agent really responds with on the other end is, here's a number, here's the number of ticks, here you go. And that's all you get. So these are multiples of the same responses, and GET requests and that kind of stuff. I'll do a bulk one and we'll see a little more about how that works. All right, so this data set is from a bulk GET request. And you can see that up at the top in the summary line. It says GET bulk request. And it asks for the part of the tree, the hierarchy that'll go on. You can see the next one, the response that it gets back is part of the tree. There's so much data, it can't get it all back. It actually took this much to get all that information we put in the table, all that kind of stuff that we put in there. It took that many packets to go back and forth. So you can imagine how many more packets it would be if we were doing individual gets for each piece of information. There'd be a lot of packets going across the network. There was a time when that was a bit more of a fear. Now that's somewhat less of a fear. Networks have evolved quite a bit, a lot more bandwidth, a lot less latency problems. But when SNMP was originally created, there was some fear that we would overwhelm our networks with SNMP flurries of packets as we did zillions of gets all the time. So bulk was created to solve that. We can see by looking down here in the bottom, it's very similar looking to a get. We've got versions and community names. We've got IDs. And then we've got this, OID. Hey, I want to see this. It doesn't really get interesting until we see the response. Now, the agent is going to know, hey, this is a bulk request. So that means don't just answer once. That means take all the answers and bundle them up. So that's why we see it's a bulk request and a bulk response, because it'll know. It actually says it's a GET response, but you'll notice that there's a lot more data in it than one thing. So we can see as we scroll down here, there's a variety of data as it goes through. We can click on some of the other ones and we'll see tons and tons and tons of data that begin to come through. And some of this data we should have seen earlier in some of our other, gets or bulk gets when we did that kind of thing. Well, I hope you've enjoyed this overview of SNMP. There's certainly a lot you can do with it. It's kind of the beginning of network monitoring, so we hope you've enjoyed it and learned something. We'll see you next time for the next Tech Nugget.